Hello. I'm just testing the mic again. We are live. It's quite late where I'm from, and hopefully I will finish tonight's idea till the end before I get too tired. Last time I started this already, I'm interested because Kafka is one of the topics that we are working with, one of the technologies we are working with in our company. I wanted to learn more about how Kafka works because I was mostly using it as a tool and I didn't understand it properly. So the question is what you learn in this Apache Kafka 101 course. Whether you're building data pipelines, connecting microservices, or moving data across system, Apache Kafka is foundational. It's the backbone of modern data systems. This is true. I worked on 2 projects in 2 different companies. Both of them used Kafka. And I think they used it in different contexts. One company used it as a logger sound sorts. And the other one to send events. But let's do this. What do I have here? When you think about data, you probably think of tables representing objects, like inventory items or user accounts. But Kafka shifts the focus from things to events, moments in time when something happens, like a product sale, a car signaling a turn. Or a user clicking on your site. Kafka processes these events in real time, not in delayed batches. You don't store events to process later, you act on them as they happen. You don't store events to process later, you act on them as they happen. I did a video on recognizing AI, and this seems similar at least. It gives me the ick. That doesn't mean Kafka forgets events. It remembers them, and we will explore how. This shift from things to events is powerful, and Kafka supports both ways of thinking. We'll cover how to store, structure, and replicate events in Kafka and compare it with the cloud-native services like Confluent Cloud. All right, so Kafka is useful because it's been used in massive scale applications, has a lot of throughput, a lot of data, things like that. No, just introduction. I don't need more. Okay, this is some topics, but let's just do a quick review of this. Traditionally, what we think when we say data is that we consider data being stored in tables, like rows in a database table or an SQL document, which is a static snapshot of things that exist in the system. And that's how modern software and web apps are built, using the CRUD methodology: create, read, update, and delete around objects. Now, Kafka views of data is based on events or moments in time. Kafka flips the perspective. Instead of only storing what exists now, it focuses on what happened. We have an event, and I'm going to explain the event as well, but an event is something that occurs at a specific point in time. So what are events? A product was sold at a certain time. A car signaled left at 11:03 a.m. A user clicked buy now on YouTube. Or is there a buy now button on YouTube? Most probably buy now on, let's say, your own website. And each event describes something that happened. And now we can compare these two things. Now we can compare them. And we realize naturally that events are not static. Events are not tables. Events are streaming, basically. Kafka. Let me just circle it so we know we talk about Kafka. Kafka says, process data in real time. Process in real time. We are not organizing data in batches to process later. If process in real time, and we will explain this also a bit better. What this means is that Kafka stores and streams these events in real-time pipelines, not in batches that will be used later, but in real-time pipelines. Where is this? I moved it. Okay. Comparably, we can make a distinction between these two concepts. Let's say we own let me just see if my mic is working. I'm checking this quite often because at one point it just stopped and no idea what happened. Let's see. We own this was supposed to be a pepperoni pizza. It looks like a button, but this is supposed to be a pizza place. Luigi's. Okay, let's call our place Luigi's. So if you are running a pizza place like Luigi's, in the table model, we will keep a ledger with how many tomatoes or flour or cheese we have left. And at the end of the day, we see that ledger. But in the event model, in the way Kafka is behaving on and making conversations, we record every single sale as it happens. So we have two ways. Table and event. So keep a ledger with how much we sold, for example. And event record everything as it happens. So let's talk about topics in a bit more in more detail. So topics are the core abstraction for storing and processing data. Again, we already passed this because here it says the same thing that I just explained. Unlike traditional databases where data is stored in tables and updated with each new event, Kafka uses logs to record every event in sequence. This means that instead of replacing old values, each new event is simply appended to the log. Preserving the entire history. For example, if you're monitoring a smart thermostat, each temperature reading is added as a new event in the log, allowing you to track change over time. Okay, now here we are mentioning something called a topic. A topic what a topic is a category, it's a stream of events. So I'm gonna say okay, category slash stream of events. A topic is a named category where events of certain type are published. Like we have a group or a set or even a folder. So it's a folder for events where you can click and you can see all the different events that are related to this folder. Like reading the temperature as we have here. If we were reading a temperature, we might have a topic called thermostat readings. Every time any thermostat reports its temperature, we would add a new event to that topic. And the log is the ordered history. Now, Kafka stores events in a log. And the log is like this big ledger of sorts. We mentioned here that we don't have ledgers when we were talking about tables and events, but it's a big log which is append only in this order, meaning new events are always added to the end, and ordered means events are kept in a sequence. These colors are too similar. It is append only and ordered. I don't know why this is important. I don't know why I color this in a different color. Maybe I should color region like this, so we know it's a pizza place. I don't know why I'm making Luigi to be more decrepit than it is, but that's a topic regarding logs and messages. Let me just add this. How is this different from a database table? Because a database usually updates values. Which means that today's temperature would overwrite yesterday's, but Kafka preserves every event, every reading's single reading is stored, so you can replay history as well. Kafka is really good for time series. Okay, so Kafka Kafka is good for time series monitoring or replaying events. Monitoring or replaying events. I want to do something else as well. Just a second. No. Now, in this case, a message is an individual element. I think we already talked about about messages, but the message is an individual event. Each event in the topic is called a message. So we have a topic here, and I want to say each event in the topic is called a message. Yeah, my writing is a bit lopsided. So what else do we have? They're immutable. Topics are not queues. Okay, retention policies. I think this is more a complex stuff. But what's this? Kafka partition introduction. Partitions are the keys to scalability and distributed processing. Kafka is designed as a distributed system, meaning it runs across multiple machines, but appears as a single unified. The partitioning introduces some changes to message ordering. But what's partitioning? Here we mention it. Partitioning solves the problem. And what's the problem? The problem is if a topic was stored entirely on one machine, it would be limited by that machine's storage and processing power. So partitioning splits the topic into multiple smaller logs called partitions. And each partition is stored separately across different nodes, allowing Kafka to handle far larger amounts of data. Let me just show you a real world example of what we just did here about messages and topics. I know these are just basic, but I find myself impressed by these things. So I think it's good to reiterate the foundations. Let's say we have two thermostats in different apartments, like a thermostat A and a thermostat B. Thermostat A in apartment 1, thermostat B in apartment 2. They both send temperature readings to Kafka. So if I create a topic called temp readings, this will be the big channel where all temperature events go, the frequency, the main dude. And now let's talk about messages. Each thermostat is gonna send a new reading every minute. So how are the new thermostats looking? Maybe like this, this, this. Oh wait, I drew it. I drew it criminally. Oh, this is gonna look so bad. But okay, so let's say we have two thermostats, and I don't know why I love to draw. So we have two thermostats, and each thermostat sends a new reading every minute. A message that consists of an object that looks like key, value, and timestamp. And the messages could look like this. So we are going in time. Then I have message one. And message one can have the key be thermostat 1, value be 17 degrees, and timestamp be at 9 o'clock in the morning. And then we have message 2. Message 2 can have a key of T2, value of 26, and timestamp of 0901. And then we can have also, let's say, M3, M4, and so on. Now let's talk about logs. A log looks like this, basically. And yes, I'm drawing it to look like a table, but I'm also doing this to help with knowledge retention. So I have here offset starting from 0, 1, 2, 3. And then I have the key, I have the value, I have timestamp, and here I have T1. The second one was T2. Let's say we by T3 doesn't exist, T1, T2. They are cyclical in nature. And then I have, what do I have here? 17, 26. Let's say the third one is, I don't know, this one is also unknown to me. And the rest, I'll just comment out. We can fill the blanks on our own. Offset is just nothing more like Kafka's index for the position in the log. And the log never overwrites, as we said, as we mentioned. There are also consumers. What a consumer does, it subscribes to the topic. So what do we have next? Now, can I move this a bit? Let me just pick up my pink color. All right, let's move this a bit. Now, what are partitions? There's this core idea. where's my pen here? And the core idea says Kafka topics are split into partitions. So someone might wonder, what does that mean? How are topics split into partitions? What are partitions? Partitions are like lanes on a highway, because we split the data into multiple partitions. It's what makes Kafka fast and scalable, because we have many brokers, we have many consumers, and they can process data in parallel. Inside a partition, messages are always ordered and guaranteed, but across partitions, maybe the order is not or guaranteed. And now we have, what was the name of this? Temp readings. Let's see. We have temp readings, and let's say the temp readings are divided into three partitions. We have partition 0, we have partition 1, and we have partition 2. So if the thermostat is sending readings like let's say thermostat B keeps sending data at 0900, 09, 01, 09, 02 every minute. This thermostat is sending readings. Now Kafka is ensuring that all of these messages are staying in the right order. So how Kafka decides which partition? This is where we use the key. So if you have a key like this thermostat ID, like TB or something like that, Kafka will apply a hashing function to the key. What this means is that it gets a number, then it does. So the question is how. I'm gonna say hashing, and then I'm gonna say plus hash modulo number of partitions. No, I'm talking the whole time, and I didn't even show the board. I'm an idiot. All right. This is what happens. Now we can also have it without keys. I don't think this is that thing. Oh no, I need to go back. Yeah, this is where I stopped last time. Kafka brokers. What are Kafka brokers, and why are they the backbone of a distributed cluster? How long does it take? We have in total 16 classes. I think I could do it till 8, maybe 10, and continue the other time. But let's do it. So what are brokers? Brokers are the servers that store data and handle all data streaming requests. When you run Kafka, each instance of Kafka processes as a broker. And a group of brokers form a cluster. So what is, no, I clicked on something. What is Zookeeper? If you are using a cloud native service like Confluent Cloud, the details of broker mostly upset. We don't need this yet. So this is the summary. All right, so all of this is basically saying the following. Where's my tablet? So a broker is nothing more than a Kafka server. Let me just write this. A broker is nothing more than that. Kafka server, sorry, process, not the Kafka server. So we can run a broker on a physical machine, a virtual machine on the cloud, or even on Raspberry Pi. I think the article said that. And each broker, oh no, I'm a bit tired. Each broker is storing stores data, which are partitions, and it handles client requests. For example, let's say we have broker one stores partitions 0 and partition 1. So broker 1 stores partition 0 and partition 1 in of a certain topic. Let me also add this of a certain topic. And when our app writes to this topic, like temperature readings, it will go to whatever broker it has the right partition. A cluster means that many brokers are working together, which is a Kafka cluster is just a group of brokers. Also, Zookeeper versus Craft. I don't want to talk about that just yet. So what do we do? How Kafka application enables fault tolerance. In Apache Kafka applications, how data remains durable and fault tolerant. So basically, yeah, let me just read through this and I'm gonna explain it. Now, we have brokers. Brokers are storing partitions of a certain topic, as we said. But we want also to keep copies of partition on multiple brokers. So how can we do that? Here it says each partition in a topic is copied across multiple brokers. Let me write that as well. So each partition is copied. Am I still? Is this still not straight? Wait. No, this is not what I want. I want to draw a shape, but how can I do this? No, not like that. I wanted to see, am I I know what I can do. Page template. Here I could do something like this. But this looks ugly. Okay. Just have some guidelines while I'm writing this. Now, on the concept of leaders and followers. Leader handles all reads and writes. Followers, they keep in sync by copying from the leader. Like, if we have a partition 0 with the application factor of 3, it means that the broker 1 is the leader. Brokers 2 and 3 are followers. And when a producer sends thermostat B's rating, it goes to broker 1, who, which is the leader, and the broker 2 and 3 pull the new message to stay up to date. Now. So what are producers? What does it mean to write data into a pipeline? Let me just read this. So we also have a snippet of example code. Good. When sending messages, the producer library handles much of the complexity behind the scenes. It chooses which partition to send the message to, either through round robin or by hashing the message key. Okay, so is this more confusing than it should be? I believe this is made a bit too confusing for our own good. We don't need it to be this confusing. So let me switch back to my tablet. And let's see. First of all, let's do a recap. A producer is connecting to the cluster using the brokers. And we can configure it with settings like bootstrap servers, X, and so on. We can use producers to send messages. Topic plus key plus value plus optional keys. And Kafka doesn't care about the features. So how could we install this? First of all, we would need to install Kafka. I don't think the command is good, but we need to install Kafka. And then we have here, it says producer. Here is it called Kafka producer, but I think in Python, the object in case the object that we are interested in is called just the producer. So the producer manages the connection to the cluster and handles message sending. What we need to do is we will need to create a config object. And here it says, to configure a producer, you provide a set of properties, key value pairs that include important details, like. So the config object will have two properties, one of them being bootstrap.server, and bootstrap server is a list of brokers that the producer can connect to. It only needs a few to discover the rest of the cluster. And we have X. The X, which is the level of acknowledgement required from brokers before considering a message successfully sent. Now, we have the producer object. We explained the config objects as well. What else? Properties config, load properties, Kafka properties. All right, so these are the properties that we created. Producer is new Kafka producer. We would actually do the same thing in Python. Let me just delete this. We will do the exact same thing in Python, only it's not called Kafka producer. I think it's called only the producer. Okay, so and then I can say another example. So I can have thermostat reading, and it's gonna be a new thermo reading. And what will it have? It will have some options like kitchen. I'm just gonna copy it from here. Kitchen 32 Celsius. I have no idea what these options here are. Thermostat reading. When sending messages, the producer library handles much of the complexity behind the scenes. It chooses which partition to send the message to, either to round robin or by hashing the message key. Okay. Oh, damn, I need to stop this now. I'm sorry. We're gonna continue tomorrow.